In this video, I'll explain how I built this TV table out of a BMW E30 subframe, some scrap metal, and a few pieces of walnut. Let's get into it. The subframe is a cast aluminum part and it forms the base for the table. I'm going to be bolting other components to the top, so I need it to be flat. I'm using a Bridgeport vertical milling machine to flatten it, and the tool I'm using is a 5-flute 3-inch carbide face mill. Note that the feeds and speeds used throughout this project are somewhat eyeballed, as I was too lazy to actually look them up. This part is quite large, far too large to easily clamp in the machine vise, so I'm using a series of hold downs to hold it to the T-slot bed, but still the unsupported distance across the length means I have to take small passes to reduce chatter. I limit it to about 5 to 10 thou per pass. This is some scrap steel tubing that I'll be using for some of the lower vertical spacers for the build. I started by cleaning the oxidation off the tubes using a bench wire wheel. I unfortunately don't have footage of this part, but I'll explain the tool and the process later. Next, I'm roughly cutting the tube to length. I'm using a cold saw here, which is essentially just a rigid low RPM circular saw with flood coolant and a vise to clamp the part. And I'm using it as shown here in the video, just clamping the tube and cutting through it. One other thing here is that I'm using the black hardstop at the end of the saw to repeatedly cut this part to the same length. Now I'm using the Bridgeport to precisely finish the tubes to length, using a 4-flute carbide end mill. I'm taking light passes and double checking the length using a pair of calipers, not shown in the video. It's not perfect. In an ideal world, I'd finish the tube surface on the lathe first and then clamp it using V-blocks in the machine vise, but this should be good enough for this application. I'm now making the base plates for the pillars that will be used to bolt to the subframe. I'm squaring a larger piece of mild steel bar stock on the mill before cutting it, thus ensuring that both base plates will be the same thickness and width. I started using some high-speed steel tooling that the shop had in stock, but switched my own carbide tooling as it was sharper and yielded a finer surface finish. The part is positioned on the machine vise as shown in the video. I'm now using my face mill to finish the top and the bottom. I used parallel blocks to keep the part horizontal and tapped the part with a rubber mallet during repositions to ensure proper alignment. After cutting the stock on the cold saw the same way I cut the tubing, I took the bar stock to equal length on the mill, and I'm starting here by squaring the side of the stock using a 4-flute end mill. I take the part to its final length by arranging both parts vertically as shown, so both parts end up at the same dimension. And then of course taking small passes individually with a 4-flute end mill. These parts will attach to the subframe through 2 through holes in the frame, so I needed to drill a threaded hole in the center of each part on the mill. I unfortunately forgot to video the drilling, but I used a threading machine that the shop had to tap the holes. I don't know what it's officially called. It essentially works like a tap wrench, but constrained to rotate coaxially to whatever hole it's tapping. Shown here is the bolt used to hold the bracket to the subframe. I'm marking lines of tangency to define horizontally where I need the tube to be positioned, and using a square to orient it normally to the subframe. I'm now using a TIG welder to weld the pipe to the bracket. I start by tack welding the tube to the bracket and then make full welds using some stainless steel filler rods so the welds look a little cleaner. I'm running at about 140 amps, but I'm taking it easy on the foot pedal so I only use a fraction of the actual power unless I have to. You may notice me doing some weld gymnastics here. Ideally, when welding a rotational or circular part, you'd be able to rotate the part, thus making welding easier because you can stay at one position. This assembly is large enough that I can't really do that, so I have to be the one rotating about the part, making it considerably more difficult. I'm using a piece of mild steel square tubing from an old project as the base for the lower shelf of the table mounted directly on top of the tubular spacers, and I'm reusing a flat bracket made of mild steel to make a flat surface to mount the arms for the tabletop. Unfortunately, this flat bracket is covered in a clear coat of spray paint, so I'll have to wire brush that off. The wire wheel I mentioned earlier is used to clean the clear coat off the flat bracket prior to machining. This tool is relatively straightforward. It just sort of turns on, rotates, and then I can take a series of light passes and the wires sort of clean the debris off the material. The next step is cutting the bar stock to size on the cold saw, essentially the same way as I cut the tubing. I'm also using a similar technique to the bracket to dimension the bar stock on the milling machine, and I'll refrain from repeating it so as to not bore you. Seen here are the finished parts as they'll be welded. Now it's time to weld the surfaces I just finished machining to the square tubing. I start by tacking the part, positioning everything using a 45-degree welding mag clamp, and then making the full welds afterwards. And the holes in these surfaces, while unsightly, may actually be beneficial here, allowing a path for the gas inside to escape as the TIG torch transfers heat to the part. I'm now making the arms that support the frame for the tabletop. These will be circular, but will have ends made of square tubing, which I'm first wire wheeling and then cutting to size on the cold saw. My camera unfortunately cut out before I cut the cylindrical tubing, but the process was essentially the same. I'm using a machined piece of steel as a makeshift right angle to align the parts prior to welding and holding the parts by hand as I tack them. It's a pretty crude way of doing it, but it gives me a bit of extra freedom to move the parts around, which is important here as I need to rotate them several times to finish welding everything. Before welding the arms to the support for the lower shelf, I'm wire wheeling the previous welds clean so as to prevent future weld contamination. As C-clamps won't work particularly well in this context due to the angle between the arm and the tube stock, I'm actually using a heavy piece of steel to hold the arms to the tube support during welding. This actually didn't work all too well, and the part deformed enough that the weight actually fell off a couple times, one of those times on me. I ended up just tacking one side and hammering the part flat, and that seemed to work alright. Now it's time to put everything together. I initially tried using the same method of weighing the tubing down to brace it against a series of spacers, but eventually I just had to C-clamp everything together. It seemed to work acceptably at the end. I decided to throw in a couple of, I guess you could call them tie bars between the two columns supporting the square tubing, as I was worried about the parts moving once unconstrained. I used a couple partially threaded rods and started by first cleaning them and then cutting them to size in the cold saw. After cutting the parts, I tacked them to the brackets on the frame before loosening the bolts holding the table structure to the subframe. Embarrassingly, I actually forgot to make some of the full welds connecting the columns to the square tubing, so I'm remedying that here. I'm using a couple old pieces of angle iron to build a base for the final tube supports for the frame beneath the tabletop. I actually cut these pieces of angle iron to size as part of our previous project, so I now only need to weld them. I decided to make the frame supporting the tabletop itself out of a few pieces of angle iron. I started by cutting the pieces on the cold saw. While the C-clamp unfortunately obscures the view a bit, the welding setup here is pretty simple. I'm using a previously machined piece of steel and a C-clamp to hold one part and a welding clamp to hold the other, checking squareness with a machinist square and welding parts two at a time before putting the entire assembly together, and then reinforcing all the welds and finally grinding the welds down using an angle grinder with a flap disc. I'm using a series of leftover pieces of stainless steel tubing that were already roughly cut to the right size as arms to connect the structure of the table to the tabletop mounting frame. I used I-beam spacers to hold the structure up and center the part prior to welding by measuring diagonals. Finally, I'm wire wheeling the welds off, primarily for aesthetic purposes. I'm using a drill with a wire wheel bit here as it's just more maneuverable than an angle grinder. I have two parts left to make, the tabletop and the lower shelf. I chose walnut for the wood as I did for my last table build. I started by cutting the plank I'm using for the lower shelf to length on the miter saw. Then I planed it to parallelism on both sides using a 14-inch planer. I unfortunately lost the rest of the footage for the lower shelf, but it would include the joining, table sawing, and sanding of the top down. Cutting the tabletop went somewhat similarly, except I couldn't find a plank wide enough, so I had to glue 3 planks together and then plane them to parallelism on a wider planer that the shop had. Now this wood was not straight at all, and as a result it took quite a while. I had to take very light passes and occasionally flip the wood over to stop it from getting caught in the middle of the cycle. After plugging some of the knots in the wood with epoxy, I sanded the part to about 320 grit and rounded the edges with a handheld router. I don't know the radius of the bit off the top of my head, I just sort of eyeballed it. I applied a natural stain to both of the wood parts and then a few coats of polyurethane. After securing the tabletop to the frame with wood screws and the lower shelf with countersunk machine screws, this build was complete. I hope you guys found it interesting, and if you enjoyed this video, feel free to like it, and if you'd like to see more, feel free to subscribe.